Hello there everybody, this is HaMu back on stage to give you an introduction to the ModPanels CV control board rack extensions. As the name implies, these are general purpose control devices for CV control of your racks. They come in 3 versions, mainly differing in the number of controls. It is my hope and belief that not only CV freaks, but also users who usually don't get much excitement from swinging cables will still find some good use for these devices, especially within live setups. Let me start with a brief summary of the general purpose of it all. The primary idea of the ModPanel concept is to gather all your most frequently accessed parameters in one place, and there are lots of controls available. Instead of addressing your remote control surface to device parameters one by one by remote override, give your controller a mod panel and have all those parameters mapped by simply linking the mod panel to the remote surface. There are also outlets for MIDI keys and performance included, so you will be able to use several mod panels in your rack and switch between them on the fly. Just set your controller to follow the selected track in Reason's main sequencer, select tracks from mod panels, and go on playing. Maybe you're used to doing like this with combinators, and in some sense you may think of the mod panels as sort of replacing your combinators, or rather complementing, as add-ons if you like. Let me just quickly show you what I mean, and be patient, I will return to the setups again later. In this demo rack there are several mod panels with their tracks adjacent in the sequencer. By selecting previous or next track, I can thus quickly move focus between the mod panels. And my MIDI keyboard, as well as my BFC 2000 remote, is following selected track. The mod panel 8 is the one creating the ambient loop you hear in the background. It's not wired up for keyboard playing. You can see that there are no cables connected to any note or gate outputs. But from the BFC I can control the sounds. I can change lots of parameters. For instance, activate a pattern for the guitar instrument. And I can change device patch back and forth. Let's leave it at the low-down setting. The mod panel 12, however, is set up for playing notes from the keyboard. The first note and gate pair goes to an NN19, a bassoon, while the second will play the Maelstrom Vesper. Final version, the mod panel 16, is just provided with a single NN19 organ only for this demo. In this case, the sequencer CV note and gate is fed back to the combinator itself, to make it address any and all instruments within the combinator. As you saw in the sequencer, there are a few more mod panels in there, and I'll come back to these later. I think you may now be ready to take a closer look at what we can find up front of the mod panel. There are a number of separate areas and functions we can identify. The control widget area, where all the controls are found. The patch handling area, including the hold outs button. The MIDI received area, with sequencer CV and performance outputs. And at the very bottom, the channel commons area. We'll now take a closer look at each of these areas and the parts therein. The fundamental part of the mod panel is obviously the control widgets area. The actual control widgets are those that connect to an output socket at the back, and these are the big ones: the knobs, the green buttons, and the vertical faders. For each control there is a tag tape and, in most cases, a mode switch. The controls are organized as a number of channels, and across these are 6 rows of similar controls. For each channel we find the following controls: 3 knobs A, B and C, a momentary button, a toggle button, and finally a vertical fader. The way the controls are organized as channels is mainly for ease of reference and overview, and you're of course free to use any control for any purpose. In addition to the actual controls, there are also a number of output mode switches in the control area. For knobs and faders, these will switch on to bipolar mode, while for the buttons they switch on to inverted mode. The unscaled, we'll come back to scaling later. The unscaled output range for unipolar mode is 0 to 1 volt, while bipolar out levels go from -1 volt to +1. The buttons will output an unscaled output of 0 volt for off and 1 volt for on. Unscaled inverted outs are of course 1 for off and 0 for on. For the ModPanel 16, the mode switches for knobs and buttons are reduced to 1 for each half of the row to fit within the panel width. The tooltip of the controls are presented as percentage of the total range, so you'll see the same figure independent of the current mode. Momentarily flipping to the back panel, we can see that for each control there is a corresponding output socket at roughly the same position as the control on the front. Over to the patch handling area. This includes the standard patch display and the patch button group, but also a hold outs button, and for good reasons. Patches for ModPanels are strongly related to the context where the device is utilized. Due to this, only a few patches are included with the device, but you are encouraged to check out the device patches that come with any of the combinator patches available from the product pages at Propellerhead and HaMu. For instance, the patches you see in this presentation. Patches are also an essential part of the ModPanel concept, and you should expect to save and reuse lots and lots of patches. When working with a specific setup, for example a combi patch, it's best to keep all relevant patch files in a folder of its own, so that you have easy access to these and only these patches. The holdouts button requires some explanation. When the holdouts switch is on, your control changes will not affect the outputs until you release the switch again. This can be used for manual changes as well as for patch changes. Notice that the holdouts button itself is part of any saved patch, so you will in advance decide what will happen after loading the patch back. If a patch was saved with the holdouts on, it will not affect your outputs when loaded until you release this switch. One way to use this is to start out by saving all patches with holdouts activated in a dedicated folder. After this, you can select a patch by stepping up and down until you find the one you need, and only then you release the holdouts. All this can be done from your remote control surface. No need to fumble for the mouse. The next part of the front panel to look into is the MIDI received area. The ModPanels are all able to receive MIDI note events and let sustained performance be applied to outputs. ModPanels 8 and 12 also receive and output all performance events to separate outputs. ModPanel 16 has no performance outputs. And the ModPanel 16 also has only one pair of sequencer CV note and gate outputs, while ModPanels 8 and 12 both have 8 pairs between which the received note events can be distributed. The following description of the note events distribution is however still valid for all 3 devices. Note events will only be distributed among the CV pairs that are active. So how is it decided which pairs are active? Well, if at least one of the note and gate out sockets has a cable, this pair and all with lower numbers are considered active, even if they are not connected. When a note on event is received, it will be directed to the first active pair which is not in use, that is, its gate is off at 0. If all active pairs are already in use, then the new note on event will be distributed to the pair where the oldest note is playing. The due note off corresponding to this oldest note is ignored when it eventually arrives. This means that the old note will still sound and the new note is added. Gate off for this CV pair will be sent out only when the latest added note distributed to this pair goes off. Received MIDI sustain has its separate output for ModPanels 8 and 12, but in most cases we want it to affect the distributed sequence CV outputs directly. Default setting of the ModPanels is to make it so, even with the ModPanel 16. But there is a switch button to optionally turn direct sustain off, in case you only want to use your sustain pedal signal for other purposes. The performance outputs will directly reflect the received MIDI performance input events. Notice that the pitch bend is a bipolar signal, while the rest are unipolar. We've been looking at the control widget area, the patch handling area, and the MIDI received area. Finally, we have, down here, almost unnoticed, what we may call the channel common widgets area. There is a channel common tag tape with bold font. The intention is to use this to indicate the use of the entire channel, while all other tag tapes are designated to specific controls. There is also an indicator reflecting the scale amount factor. Let me explain. At the final stage before a control level is sent to its output socket, that level is multiplied by this scale amount factor. The scale amount setting is only accessible through a CV input socket, one for each channel, and reflected on the front panel by a LED bar. An amount factor of 1 or higher will show a bright green light at the right end, 0 will show an all dark LED bar, and negative values will lit an orange LED with -1 at the left end. The scale factor input level can be any bipolar value and will affect all outputs of the channel. For buttons, however, the absolute value of the scale amount is used, so there will never be any negative button output. That is, a scale factor of -1 will again leave +1 on the output for the on state. Let's look at this so you see what I mean. Finally, a scale amount factor of 0 will of course in effect turn off the entire channel, setting all the channel control outputs to 0 volts. I will end this introduction by giving a few hints and tips on how to use these devices. Again, look for download links on the product pages to get your own copy of the combinators, device patches, and the entire song, as used in this introduction. Let's take a look at the implications of letting your remote surface follow the selected track, and a little on how you can use this. You are free to have the mod panel inside a combinator, or you can keep it as a free-floating device with cable connections to devices you want to control. There are, however, situations when you can use the CV inputs of a combinator to affect the mod panel itself, and then you must of course keep the mod panel within that combinator. When a mod panel is included in a combinator and there are tracks for both, you may find that the combinator track will cling to the mod panel track in the sequencer. If you want to move together all mod panel tracks for easy switching, you may have to delete that combinator track. Since you're able to connect the note and gate outputs to combine the sequence CV inputs, you can use as many combinators as you need to access parameters for which the device has no CV inputs. The limit of the 8 CV inputs of a combinator is now mainly an inconvenience, not a showstopper. The mod panel 8 setup in this demo rack controls no less than 6 different ID8 instruments, which, as you know, have no input sockets at all. Each of these ID8s resides in its own combinator. If I was a fluent keyboard player, I could indeed use the note and gate outputs of the mod panel, but instead I prepared this setup with a number of matrices. One matrix for each instrument, and these are all within the combinator, so that the pattern select can be controlled via the CV inputs of the combinator. It can often be a good idea to reserve a channel or a number of controls of a mod panel for internal connections. A common application can be to turn off a channel by setting its scale input to 0 volts. By the way, don't use a button on the channel itself, which could eventually force you to remove the cable to enable the channel again. Do you need to synchronize your patch changes with the transport, or maybe with the other CV triggers? There is no built-in functionality for this, but there is the hold outs button. If you place your mod panel inside a combinator, you can control the hold outs button with the CV signal. I have prepared a combinator patch showing this, so let's take a look, shall we? This patch is similar to the mod panel 12 we looked at earlier, but I added some stuff and I will use a matrix for creating the note events. There is a matrix in that other MP12 too, but I never showed it. Here I use several note and gate outputs, and all but the first one goes to the Maelstrom. I use the free CV8 gateway from DVD Technology for this, rather than the HaMu Mingler, just in case you don't own the Mingler. Thank you, DVD Technology. Anyway, with this setup, the NN19 will play every first note after a silence, and all added notes, while the first note is still playing, will be played by the Maelstrom. How about the synchronization? It's easy to use a matrix for this. using a unipolar curve output going low only when outputs should change, but other similar setups should be possible. As you can see, the hold out button will go dark only now and then. This is controlled by the CV4 input to the combinator and comes from the curve output of an additional matrix, which only goes to 0 during the last note of the pattern. Care should be taken when abrupt changes are included, especially mode changes and such. Safest is, of course, if affected devices are silent before a patch change. Continuous parameters will mostly give the smoothest changes, just like when you change on the device itself. And finally, the matrix may not always be the ideal sync source, since its own sync is sometimes a bit peculiar with relation to the recent transport. If you really feel you need to have a transition time between the old and the new level of a control, for instance after a patch change, you could use some kind of envelope or slope generator. MIDI Tapper from HaMu is one such device, but I must admit that there are others more suited rack extensions for this. Within short after the release of the ModPanels, HaMu will release a mod slewer, which will have 12 simple separate CV slew rate shapers. This is just a leak peek of what it may look like in cooperation with a mod panel. I've gone a bit to the extreme here, just to emphasize the results. Notice that the holdout's off period needs to leave some time for continuous change of parameters. Well, that concludes this introduction presentation. I hope you enjoyed what I showed you, and see you again soon. Bye bye.